This video is Fusion Masterclass number 4 about mirrors by Dr. Matt Moynihan. So let's take a look at the mirror effect here.
Essentially two magnetic fields that reflect particles. The reflection occurs because of something called the mirror effect. As a particle moves from a low-density magnetic field to a high-density magnetic field, it experiences a Lorentz force, which causes it to corkscrew around the magnetic field line. So you can think of a particle like just take a typical ion. Imagine it going clockwise around a magnetic field and traveling down this magnetic field, which is a low-density field where the lines are pretty far apart. And then the flux and the magnetic field gets tighter and tighter and tighter. And what happens is, as that happens, the particle starts corkscrewing much faster, and the number of turns gets closer together. So it kind of scrunches together as it goes further along. And eventually, under certain conditions, the particle will flip directions. The magnetic moment along the line will flip directions, and the particle will be reflected off of that magnetic field and continue corkscrewing out into the low-density field lines. So I say under certain conditions because the effect doesn't work all the time. If the approach of the helical turn is at a high enough pitch angle, it will leak through. And
holy shit, chat. This is definitely, I would say, what's my percentage? 95% sure this is exactly what's in the orbs in the MH370 videos. The black lines that are coming out of the orbs, they're not solid. They're not solid. It almost looks like someone's got a spray can, like if you would use the paint and use spray can paint on there. And I think that the reason is because they are controlling whether or not the cusps are closed in the magnetic mirror, whether or not they're going to allow the particles to escape. And so if they allow them to escape, then they're winding, they're helically winding, like he says, and they're going faster and faster and faster, and they're escaping out the front or out the back, out either side. They can control which side they come out of. So what you've got is you've got these particles coming in, and then they're getting trapped in here. And they're getting trapped because of the cusp. What's happening is he's saying is that what you do is you cusp, you squeeze the openings of either side down, and you make it more bulbous in the middle. And by doing this, when the particles approach that cusp, they have to squeeze down, and they get faster and faster and faster. And what happens is some of them reflect back. This is your magnetic mirror. This is why it's a magnetic mirror, because the configuration itself causes the particles to not escape and to bounce back. So then all you would have to do to control this is basically change the size of your cusp on either side, just actively. Change your cusp just like a fire hose. Determine the pressure you want to shoot out or block it off entirely.
the way they model this is they have something called a loss cone. So it's a three-dimensional representation in mathematical space of particles, and things inside the loss cone have a high enough pitch angle that they get lost. Things outside the loss cone are not lost, and they are reflected. So that's a mirror coil. It's essentially, in the most basic sense, the basic magnetic mirror is, think of a coil, a ring, a magnetic ring that gets tighter as you get to the end of the mirror, causing that low density to high density transition where particles are easily contained and then they go to the mirror and they get reflected and they get sent back. And you put two of those coils facing each other. And essentially you've got particles that bounce off one mirror, go across the machine, bounce off the other side, go across the machine, bounce off the other side, and they bounce back and forth and back and forth. And as they crisscross in the center, they hopefully collide and fuse. That's the basic concept of a mirror machine.
I mean, chat. This is what we're looking at in the MH3. How many foreign intelligence agencies are watching this right now? I actually want to know, chat. If you are a foreign intelligence agency with the People's Republic of China or with the Russian Federation, or you're with North Korea, or if you are with Iran, rest in peace for your nuclear scientists, put a one in the chat. I just want to know. I want to get some representation of what we got out there. But by the way, yes, this is what our secret plasma orbs are using. Yes, indeed. This is exactly it. So when I'm showing you these videos of these MH370 videos, I mean, you can pretty much just tell by looking at it. That's clearly what we're looking at here. Like, you see those dark black lines coming out of it? Like, that's where the shit's shooting out of the front of those. They've got a magnetic cusp on either side, and they can control one end or the other, whether or not something comes out. And you see the bulbous plasma, why it's circular. It's circular because what we just looked at right here, like that's why, right there. There you go.
Two magnetic coils that face one another, and have plasma bounce back and forth between the two in a linear fashion, with stuff colliding in the center, and hopefully fusing.
So, I just don't get, this is where, like, I've been watching this the other day, and I'm just sitting here like, Charles Chase figured this all out for Lockheed Martin like 10 years ago. Somehow doesn't go public. People are sitting here looking at tri-alpha energy and helium fusion, which is basically doing this as well. And they're all wondering, why is tri-alpha energy, why does helium fusion have so many billions of dollars of investment? How have they been running and not losing money since like 1998, I think is when tri-alpha energy started? Well, I'll tell you why. Because a decent amount of people know that this is the secret to make fusion work. A lot of people know, and they are not throwing their money away investing in those companies. And in fact, I'd be surprised if Tri-Alpha Energy doesn't have a few secret government project contracts as well. I'd be very surprised. I mean, how are they making money? You can't run a business for 20 years losing money and still have people invest in you. It doesn't work that way. So yes, something is amiss.
Some of the bigger machines were about the size of a school bus.
Okay, we're going to skip ahead a little bit. The geometry of the baseball design, the middle one, very similar to what Paul Thibodeau, this idea that you must have anti-parallel motion is actually highly represented in the baseball design. Because if you actually look at the relative motion of the fields, you're going to see that they're pretty much trying to maximize how often the fields are aligned against one another for maximum relativistic motion. But apparently we ended up moving towards the Russian design here of these loft bars. Now, what does this look like? The loft bars here look just like the wormhole. Look just like what we did to MH370. In fact, you could pretty much argue that the bars are the hypercylinders. The bars are the hypercylinders around the craft, and you've got two rings, one on either end, and that's how you're making your wormhole, and you're kind of cut and pasting. No, I just thought that was an interesting comparison.
So William Pickles and Ralph Moyer worked on an approach called an energy capture approach called direct energy conversion.
Holy shit, chat. My mind is blowing right now. Did we just stumble upon the literal payload here? We just hit the jackpot. This is the guy that pioneered directed energy conversion. Let's go. Oh my goodness. Christmas came early. Now you understand why the topic of tonight's live stream says mirror reactors and directed energy conversion. We just found the guy that pioneered directed energy conversion. Ralph Moyer. Nobody even knows who he is, but he's a famous physicist. Okay, let's go.
Energy conversion is an exciting idea where material coming off a fusing plasma is at a very high potential energy because it's so hot. The helium ion that just came off the reaction is really, really hot.
The helium ion? Keep going.
So if you fire a beam of particles at a piece of metal that's just coming off a fusion reaction, it creates a very high potential energy in one spot. So 3 million electron volts is a good rule of thumb for this. So direct conversion basically harnesses this capability as a energy conversion approach. Particles come off, they hit the metal at some point. Let me back up. Particles come off, you apply magnetic and electric fields to sort of beat them into submission. So you kind of collimate them, get them going in the right direction, and maybe do some sort of charge separation so you have just the positives or just the negatives, and then fire them into a metal.
He's like this. We're like, can you notice how every topic is going tonight from one to the next? I'm so glad I did it in this order, because now when he's explaining this, you should in your mind be imagining the orbs, imagining a tube with superconducting magnets on it, and you've got your charged particles flowing through it. That's what he's saying here. Like, these guys, like, obviously the stuff is real. These guys were working on it back in the 60s and the 70s. They were working on direct energy conversion, plasma fusion, propulsion, all of the baselines for everything that we now know is real. But the public still has no idea. Even right now in 2025, no idea. All you have to do is have your charged particles run into a plate. It's that simple. Have your charged particles hit a plate, and what's going to happen? It's going to push you. This is going to push. It's called momentum. It's called movements. That's it. So yes, you can very, very, very easily take aneutronic fusion and convert it into propulsion by simply having your charged particles hit a plate. I'm sure there's even easier ways to do it, or more efficient, smarter ways to do it, but just from a very simple standpoint.
Wall. And what happens is that point on the metal wall is held at a high voltage, which means that you have a 3 million volt point in an electrical circuit that's consistent and steady. And that allows for current to flow elsewhere in the circuit. So that's the concept. That's direct conversion. You have material coming off, ions at a high voltage, high potential energy. It's kind of beat into submission and collimated. It goes into a wall. It creates a point that's 3 million degrees, 3 million volts, and that allows for electrical current flow elsewhere in the circuit. So that's the basic idea. It's a very interesting.
And he even mentioned non-equilibrium. Non-equilibrium is separating positive and minus charges out and keeping them separated. And he mentioned that. He said, well, you would probably separate the positive and minus charges. He's talking about non-equilibrium. And that's what David Kirkley even talks about. He says you can even get higher efficiencies if you take your plasma and you make it go non-equilibrium. And you keep it stable like that where the charges are separated, which is almost certainly why we're seeing the heat signature in the plasma orbs, because they've separated the charge in those orbs. That's what they're doing there, which is like another reason why like this whole presentation we're watching here is about magnetic mirrors. And we're looking at one. We're literally looking at it.
In one place. So two things that were exciting about that work. One, they showed a 47% conversion efficiency.
I mean, you look at this, look how similar this is to the hypersonic design, how similar it is to the compact fusion reactor. They're basically just separating the electrons, which are blue in the image that you see here, from the ions and from the neutral particles. And you can see that you've got these collectors, which presumably are just superconducting magnets that are controlling the motion of the electrons and the ions, keeping them separated. That's it.
Which is really incredible when you think about power plants today. A typical power plant today is 25% to 60%, maybe the world.
And he says this research in the 70s, they were getting 40 to 50% efficiency from doing this with fusion. 40 to 50% efficiency in the 70s, guys. So 50 years ago, they were getting 40 to 50% direct energy conversion efficiency. We only get 20 to 25% efficiency from power plants today, right now. So even in the 70s, they had proven experimental results showing double the efficiency of our best power production today. The Magnetic Mirror Test Facility. I couldn't believe there was a story like this. Here it is.
Kinds. The MFTF was the largest machine ever built. And it was finished in 1986 under the Reagan administration. And when Reagan came in 1980, his philosophy was the biggest problem is government. Government is the problem. And what he meant by that was that he wanted to simplify and strip away a lot of big government programs that he didn't think the country was really benefiting from. And one of them was the fusion program, and principal among that was the mirror program. So this was a technical down select that the nation was making, and it killed off not
technical down select. That's what we're calling it. Okay. So 1980s roll up, Reagan comes in and he's anti-big government. So he comes in and says, we got to cut all this government stuff. So what do you guys think they cut? What do you guys think they cut, chat? Anyone want to guess in the chat? 5, 4, 3, 2, 1. Let's find out.
Not just mirrors, but also FRC research, pinch research, and other fusion research programs from around the country at various universities and national labs.
I'm going to crash out. I'm going to lose my effing shit right now. I can't believe what I just heard. They not only killed mirror fusion research, but it also killed all field reverse configuration research and pinch research.
I interviewed Dr. Robert Terry, who was at NRL at the time, and talks about this. He said he was at the APS meeting, and the Department of Energy showed up and essentially said, we are going to down select to tokamaks, and that it was the dumbest idea ever. And that fusion was not at a place where technical down selection was a good idea. And I tend to agree with that thought.
And this is the weirdest part. So they interviewed the people that were in the room. And what were their reactions? The reactions were, this was the dumbest idea ever. This is where conspiracy Ashton starts to creep in. Why would we do the dumbest thing ever? Especially because the amount of money that it takes to research some of these fusion programs is basically nothing. I suspect, especially given the time frame of this, that this was a specific decision that was made to move away from research that we knew was fruitful, that we were using in military applications, and send everybody away from it. And the reason why I say this is because just 2 years later in 1989, because this is 1986, 1987, 2 years later in 1989, the Department of Energy covers up cold fusion. So you have this big thing where you kill off all of these branches of fusion. And then 2 years later, guys named Pons and Fleischmann come out and they're like, hey, I just did like a garage experiment and we're seeing water just boiling when it shouldn't be. So we're seeing over unity. We can just tell it's over unity because water's boiling when it shouldn't be boiling. And the government freaks out. They freak out because they just tried to cover this all up. And now some random people are doing a garage experiment and they're proving the concepts of fusion that is not temperatures of the sun, or at least using methods that are unconventional to produce fusion. So they had to cover up cold fusion as well. And we've been living in this world since then where anything related to fusion is taboo. Anything related to the successful branches of fusion, the fusion that actually works, is considered pseudoscience. All of the fusion that doesn't work, that's been basically proven to not work, that we've had zero results from, that's considered the real fusion. Basically, reality has been inverted.
So the MFTF was slated for closure, and they came to Livermore and essentially told the staffers that were working on it that, hey, when we finish this thing, we're going to shut it down. And at the time, it was hundreds of people working in all aspects of the reactor, designing the magnets, building the magnets, shipping the magnets, building the vacuum vessel, designing the diagnostics,
They're building a giant superconducting mirror fusion test facility. And they just tell everybody, we're going to just shut this whole thing down. We're just not going to do it at all. We spent all this money to build this thing. Where now all we have to do is just run tests on it. We're not going to do it at all. That doesn't sound like saving money to me. Actually sounds like the opposite of saving money. Sounds like wasting money and then not doing experiments that could have given us value for that money that we spent to cover up potentially successful fusion research. Do you see the reason why they don't want the MH370 videos to come out yet, chat? The reason why everybody's against me on the videos for the most part, I mean, when it comes to podcasters, is because if those videos are real, the cover-up is really gross. Like, gross to the degree where they've been hiding fusion research from us and they potentially actively suppress the fusion research from us, from the public, nefariously, with malintent. With intent to ensure that we don't figure it out from the public perspective. There deserves to be accountability for the people that made those decisions. The people that made those decisions should have their careers and their historical relevance tarnished. Even if it's Edward Teller. Even if it's Edward Teller himself. Whoever made that decision to prevent humanity from getting fusion research, They should be considered one of the worst people in the world, no matter whatever they did for us.